kth index, we have to return the value -1. First, we have to add all the numbers from different ranges and combine it into a union. Here, k represents the position after combining it. In our test case one, there are two different ranges. One is 1 to 3 and another one is 5 to 7. From 1 to 3, it is three numbers, and from 5 to 7, it is three numbers. After adding it, we have six total. So at the fourth index, we have 5. So the number is 5. The another test case is from ranges 1 to 5 and 3 to 7. Here we have overlapping ranges, where that means we have many duplicates. After combining the union, the number at the position 6 is 4. Another edge case is k can be greater than the total number of numbers after combining it. Then we have to return it -1. And the solution for this problem will be explained by Ashrita.
So now I'm going to explain the first approach, brute force approach. It's a first approach. Let's take this test case. Fine. 1 represents the number of test cases, whereas 2 represents the number of pairs. 4 is the index to be found. This represents the ranges given. So the steps need to be followed. First, we need to add all of the elements in these ranges to a new array. Which will give a new array. Right? So this is the new array. Sometimes they may contain the duplicates, so we have to sort it out, and the ranges may differ from different numbers, right? So that's the reason why we need to sort it here. Then the steps include adding all numbers, second sorting it, and after sorting it, it is very easy to find the element at the kth index. As we know, brute force is very simple, but it is inefficient for larger inputs. Like if the number of input is 10 power 9, then it may cause really time limit error. So the time complexity for adding, it is big O of m, and for sorting it is big O of m log n, and the space complexity is O of m, where m is the input array size.
So we know that brute force is not going to work on this. We are going to try binary search on it. One thing we know is that it is non-decreasing. That means it will have duplicates and it will be in an ascending order. And the union of ranges when combined is sorted. Why don't we use binary search on this? The one thing we know is we can't find whole thing. So we need to separate them and search in search spaces. First we take low as lowest of long and high as highest, and we perform binary search on these. For each time we calculate the mid, we count we count less than or equal to mid and check the count if it is less than or equal to or greater than or equal to k. By this method, we can find the kth index. How do we count if it is less than or equal to count? If the mid is greater than count, we don't consider it, and if the mid is less than count, in that range, we count all the values in that range, and if the mid is in between those two ranges, then we calculate all the numbers from the lowest of the range to the mid. We add all these and add it to count, and after checking all the ranges, we compare it with k. If it is if the count is less than k, we change high, else we change low. In this process, we can find the kth index number, and the pseudocode for this program is here. First, we take low, high as max and min value to compare it, and we check all the ranges, and we take lowest in that range and highest in that range, and we start the binary search. In binary search, we use this formula so that it does not overflow in certain cases. We initialize count as 0, and we check every given range to update the count. If mid is less than lowest, then we don't care about it and we simply go to the next iteration. Else, if the mid is greater than r, we check everything in that range. So we add everything in that range to count. Else, if it is in that range, we take everything from the lowest to that range. After this loop, we get the total count and compare it with k. If count is greater than k, we change the high, else we change the low. Again, it starts into the loop. By following this method, after all these after all these steps, we get the value in log n time and return it as low. The time complexity for this program is O of n log max, where n is total number of ranges, max is the maximum value in that range. Since they are very minimal variables used, it will be run in constant space. So O of 1. That's it. Thank you.